This week on The Changelog, we're talking about Nix with Domen Corzar. The Nix ecosystem is a DevOps toolkit that takes a unique approach to package management and system configuration. Nix helps you make reproducible, declarable, and reliable systems. And Domen is writing the Nix ecosystem guide at nix.dev. And today, he takes us on a deep dive on all things Nix. Huge thanks to our partners Linode, Fastly, and LaunchDarkly. We love Linode. They keep it fast and simple. Check them out at linode.com/changelog. Our bandwidth is provided by Fastly. Learn more at fastly.com and get your feature flags powered by LaunchDarkly. Get a demo at launchdarkly.com. This episode is brought to you by SourceGraph. SourceGraph is universal code search that lets you move fast, even in big code bases. Here's CTO and co-founder Byung Lu explaining how SourceGraph helps you to get into that ideal state of flow in coding.
The ideal state of software development is really being in that state of flow. It's that state where all the relevant context and information that you need to build whatever feature or bug that you're focused on building or fixing at the moment, that's all readily available. Now the question is, how do you get into that state where you don't know anything about the code necessarily that you're going to modify? That's where SourceGraph comes in. And so what you do with SourceGraph is you jump into SourceGraph. It provides a single portal into that universal code. You search for the string literal, the pattern, whatever it is you're looking for. You dive right into the specific part of code that you want to understand. And then you have all these code navigation capabilities, jump to definition, find references that work across repository boundaries, that work without having to clone the code to your local machine and set up and mess around with editor config and all that. Everything is just designed to be seamless and to aid in that task of code spelunking or source diving. And once you've acquired that understanding, then you can hop back in your editor, dive right back into that flow state of, hey, all the information I need is readily accessible. Let me just focus on writing the code that implements the feature or fixes the bug that I'm working on.
All right, learn more at sourcegraph.com and also check out their bi-monthly virtual series called DevTool Time, covering all things DevTools at sourcegraph.com/DevToolTime.
So Domen, you're here to tell us all about Nix. Welcome to the Changelog.
Thank you.
We are excited to have you. I've heard a lot about Nix. I hear a lot of smart people saying the word Nix. I also hear them saying Unix, not the same thing. But Nix is a lot of things from my research. Can you tell us what it is in your words?
Sure. Yeah, the way I see it, it's an ecosystem of tools that you can use to develop, build, and deploy software. In other words, I see it as a kind of a Swiss Army knife of DevOps. Particularly Nix, it's two things, or maybe even three. So that's why it makes it a bit confusing. It's the language, the package manager as the facade, and it's a bunch of concepts behind it that are very different to a typical package manager.
Okay. So where did Nix come from? Who created it and why did it come into the world?
Yeah, so I think it's almost 20 years now since Elko Douwstra started research in Utrecht, if I'm correct, in the university there. And he eventually had his PhD thesis be about Nix, and also developed the prototype in the first version there. So that's where it started. So it was essentially sponsored by grants and so on.
So it was a research project.
Exactly.
Sponsored by grants. And what was the purpose? What was its intended?
The purpose was, again, this is according to me talking to Elko many years ago, was to see if functional programming paradigms can be applied to solve packaging problems. I think that the university there has a pretty big department on functional programming research, and this was one of the areas that they tried to apply to it.
So what was your introduction to Nix then? It came much later, I suppose, than that 2001, if it was about 20 years ago.
Yeah, it was around that, yeah.
It became a research project. When did you find it and what got you excited?
That's an excellent question, yeah. I was doing a lot of Python development in 2012, I believe it was. And I was working in the community called Plone. It's a CMS, pretty old now, and not that well known as it was before. But we had a lot of packages there. I think it was about 300 packages to install Plone, and some of it depended on C libraries and so on. And, between Linux and Mac OS and all the things broke really, really often. So a friend of mine, Florian Frieserdorf, actually discovered it. I don't know to this date from who. And he suggested, look, this is like really cool research and it works already. And, we should give it a try to solve these problems. So that's how I was introduced to it. And then I think only a year or two later, I finally switched and gave it a try and so on.
And what did you find? Was there an aha moment, or was there a feature or a thing that it did that you appreciated? Because I mean, you're big into Nix at this point. You're doing the Nix.dev website. You've got the weekly newsletter. So you came to us and said, hey, let's talk about Nix. So this is something that you're excited about. What was it that got you a year later?
I think my first aha moment was, I was back then doing consulting, and we had a client in Finland. I used to use Gentoo. In Gentoo, when you rebuild everything, like you have to recompile, it's called the world. Mm-hmm. And at that client, I needed to upgrade in order to have the newest package. And then it was, I needed to compile for like 10 hours. And, back then I switched to Ubuntu at the time, and, I really didn't like the inflexibility of it. So when I went into Nix, I was like, oh, this is the best of two worlds. I can have, the source distribution and the binary distribution model at the same time. So when I tried Nix after Florian introduced it to me, and I saw that, you can like roll back, and there is like a binary cache for all the packages from open source that you just download everything instead of compiling. But you can like apply a patch and it switches to the source model. I was like, oh, this is what I need, right? So I can have both of convenience and, hackability, if I may say. And on top of that, the design, like one of the biggest features advertised is the rollback. So the way Nix does, it uses a symlink to switch between the previous and the current version, which is an atomic operation on Linux. So essentially, you can always roll back to the previous version of a system that you've activated. And, the switch is atomic because of the symlink primitive. And that was two things that were really clicked into my head. I was like, oh, this is something really better than what we have today.
Mm-hmm.
If you're on Linux, is this in some cases a replacement or an augmentation of like apt-get or apt, or is this sort of like a whole separate thing where it's purely for building and delivering software? And how do those two worlds play together between like an apt or an apt-get or something like that?
Right.
Are they completely different?
Yeah, they're completely different. So Nix replaces the whole, stack. It exposes some called imperative package management model, which is what you are familiar with apt-get. So we can like say, install a package or uninstall a package and so on. But behind the scenes, it works very differently. So there is a folder called /nix/store. And in that folder, it will put packages prefixed by a hash, the hash of all inputs that Nix needed to build this package. So the idea there is that Nix will always guarantee that the result of the binary output, when you build a package, is the result of all the inputs that it needed to build this package. Then it will expose, like I said, the command line interface over that, so you can, uninstall, search, and so packages. But what allows this flexibility of rollbacks is that these packages are completely installed in separate folders. Like in Make, you have prefix, where you can say where it will install something. Mm-hmm. And this is the Nix store / and then that hash. Mm-hmm. It's called like a global store or something like this, where you have all the packages then.
Right. I think some of the confusion with Nix is because, and I like the way you describe it as an ecosystem, is because there are different aspects to this. So there's Nix OS or Nix Auth, there's Nix packages, there's Nix, which appears to be a language. There's a Nix language that you use in order to configure things. And then there's also a shell, which maybe that's part of all that. Maybe explain the ecosystem in different bits, because when I read about NixOS, I think, is this a Linux distribution or is this a package manager? And
right.
Kind of where Adam is like, can I use it with Debian and replace apt-get, or do I need to like be using NixOS?
Right.
So help us understand the ecosystem better.
Yes. So usually the answer to this question is yes, everything.
Okay. Ultimate flexibility.
Yeah. So at the very core, it's a bunch of design concept and language. The language allows you to write something to this Nix store and create a folder or a file and so on. But then there are building blocks on top. So you have, as we said, the language, the package manager, which can be installed on, officially supported on any Linux distribution and macOS as well. And there's people who ported it to FreeBSD. There's people in high performance computing. There's some people who are trying to use it there. There's a few blockers, but it's been successfully used. So besides the FreeBSD and there's, a bunch of smaller projects that people use it in, some niche areas. But the main supported one is Linux and macOS. Mm-hmm. So then there's the OS, which is a Linux distribution built on top of the package manager. So you can deploy. It's for desktop and servers. So you can have, for example, I run NixOS on my desktop and my servers. You have, I think, GNOME and KDE as two desktop environments, and there's a few others as well. On the servers, it's even bigger. There's tools to deploy, like with Terraform, or there is a Nix-specific tool called NixOps, and you can deploy to like Amazon, AWS, Amazon, and Google, and a bunch of other providers. So it's big on the DevOps side. And then there's different smaller parts of the ecosystem, like Home Manager, which allows you to manage home files, .files, and that's a separate project, but still it's done by Nix. And people do all kinds of crazy stuff with the Nix API to build and, deploy software. So it can be applied to any of these things.
Kind of nice because it's approachable in that way. If you're already just running macOS or maybe running Ubuntu as your development environment and you want to use Nix Package Manager and have your own little isolated Nix environment, you can do that. So you don't have to go all in. But if you want to go all in, maybe a year later, you're loving it and you're wondering, why don't I just use Nix for everything? You can set it up as your desktop environment and run the entire distribution of Linux that has Nix at its core.
Yeah, exactly. I think the easiest way to get started is to use the Nix shell, which is allows you to, it's kind of like virtual env, but system level, or Ruby environment, or all these language specific tools. And you can expose then a shell environment for your project with a bunch of tooling, which is reproducible, and you always get the same kind of tools. And it's pretty nice because you can share that between Linux and macOS. So you just drop that file in, and that's a really good start, I would say. And the other one is to manage to be able to install a bunch of software that otherwise, your Linux distribution doesn't expose it, or something else, Those are the two common paths.
So at the core of Nix is this package management system, which is purely functional, as it says on the tin. And then so in addition to that, you have Nix packages. And this, I assume, is similar to what we'd expect with an apt-get or with a homebrew, where you have like a package ecosystem of packages that you can install. Tell us about that. Or are they precompiled binaries? You said that most of them are, but you can patch them and you can do all this different stuff. I did find the package management, website and started searching for a few packages. Some newer ones that I thought, oh, maybe it's not in there yet, like Dino. And I was like, oh, sure enough, there's a Dino package. So what all is in there, maybe what kind of stuff isn't in there. Tell us about that ecosystem. Because when you buy into something and you want to use some packages, then you're going to want them to be there. And there's a lot of packages in the world. So how does a package become a Nix package? Talk about that side of the things.
Okay. Yeah, so this is called the Nix packages part of the ecosystem, which I've kind of left out. But it's on GitHub, so it's kind of easy to contribute. You just open a pull request. No, we're not there yet, but we should hit 100,000 pull requests pretty soon. It's probably one of the biggest projects on GitHub right now. I would say it's pretty easy to contribute. And there is a project called Repology where they kind of track different distributions and package managers. As far as I know, Nix Packages is the biggest project out there. Now, to be fair, like Debian and others are pretty strict what goes in and what doesn't. And Nix Packages is just kind of like an ever-growing one. But I would say there's almost any package you've wanted to install is in the Nix Packages collection. And yeah, everything that is free is also built from source, and there is a binary for it, unless it's broken or some other. But yeah, by default, we build all the packages on a part of the ecosystem called Hydra, which is kind of like a CI system also built for Nix. And it's the build farm, which has like Mac OS, Linux, and also ARM V8, I think, machines to compile these things and provide binaries for everyone.
It seems like the core tenet of it really is around reproducible builds. It seems like that's the core feature that everything sort of hangs upon, right? Like even in the documentation when it talks about Nix, it says, a lot of what you've already said here, but it says this means that it treats packages like values in purely functional programming language such as Haskell. They are built by functions that don't have side effects and they never change after they've been built. So really around this reproducible builds scenario where you want to ensure that the package you're using has never been changed, it has been altered, and then some other, features such as rollbacks or, as you mentioned, atomic upgrades and rollbacks seems like other core tenets to why you might use it, and everything else is sort of like similar in nature to say apt-get or apt or homebrew. Like a lot of the reasons why you use it is very similar to that, but the core tenet being function or being reproducible builds, being sure that the thing you're using is in fact has never been changed, and what compiled it didn't inject any sort of side effects as a process.
Yeah, that's correct. I think there's a lot of benefits, and one of the jobs that we haven't been doing that great as a community is really enumerating all of them. Because, like one side of it is this page of reproducible builds because of the, purely functional model. But I don't like to explain it that way because I think a lot of people might not be familiar with these terms and what it means in the context of package management. And we haven't been really able to put up a good way of what are the benefits that are the consequences of that design. So yeah, you've enumerated a few, and there's a bunch of others. So on nix.dev, I have I've come up with a list that is incomplete. But yeah, like rollbacks are the number one feature. Mm-hmm. One of the cool things is that you can build your whole system remotely on a different machine than yours, and then just copy, everything to a different system and just say activate, and, in a matter of seconds, you have the new system running there. So the build and deploy or activate phase are completely separate, which is especially nice when you have more than one machine and so on. So Nix as a language evaluates to so-called derivations. These are the instructions how to build a package, and then you can copy those to another machine, and then you can realize them. That's the term, which goes from this derivation into the actual, build, which is then produces the output. And on the way, you can also, instead of building, substitute. That's the technical term we use when you say you download a package for this hash, which is then the binary you get instead of building. Yeah, that's the kind of pretty nice benefit, I think.
This episode is brought to you by our friends at O'Reilly. Many of you know O'Reilly for their animal tech books and their conferences, but you may not know they have an online learning platform as well. The platform has all their books, all their videos, and all their conference talks. Plus, you can learn by doing with live online training courses and virtual conferences, certification practice exams, and interactive sandboxes and scenarios to practice coding alongside what you're learning. They cover a ton of technology topics: machine learning, AI, programming languages, DevOps, data science, cloud, containers, security, and even soft skills like business management and presentation skills. You name it, it is all in there. If you need to keep your team or yourself up to speed on their tech skills, then check out O'Reilly's online learning platform. Learn more and keep your team skills sharp at O'Reilly.com/changelog. Again, O'Reilly.com/changelog.
So let's say I want to use Nix to install Firefox, and I type Nix install Firefox, or you can tell us what you would type. Or what do I do? And then tell us what Nix would do. And then we'll go from there and talk through what that provides and why I might want to do it that way.
All right. Oh, there's quite a lot going on behind the scenes, so let's go through each step. If you say Nix install Firefox, Nix will first of all try to see where you're trying to install Firefox from. And by default, it will use Nix packages, which is the official one of the sources it can install from, but it can be anything. So we'll skip that part for now. By default, it will use Nix packages. And then there is a top level file in Nix packages called all packages. And you can imagine this as it's kind of like JSON. Nix language is kind of like JSON with functions. So in there, you'll see a key Firefox, and it will point then to a file, which will import that file. And inside the Firefox file, firefox.nix, wherever it is, there is a description of how to build Firefox. So Nix has, in the language, there is a primitive called derivation, which is kind of like the core of the whole concept. And in the Firefox case, it will say, there's a bunch of dependencies. You have to run make with these flags and a bunch of other things. And this derivation function is really the core of it. And what it will do is it will first go through all of the dependencies and build those, of course, all to the bottom of it, which is the bootstrap, something we call the bootstrap, where we build the minimum possible environment. And then it will build all those dependencies up to Firefox. And all of those dependencies go through this derivation function. Okay, so what happens in there is the derivation function gets a bunch of inputs, which you can imagine as like key value pairs, essentially. And it passes that to a builder, which is some kind of an executable. By default in Nix, all the builders are done in bash, but you can have an executable as a builder, essentially, and pass it all the inputs to it. And this builder, once it will be executed, is run in a sandbox environment. So, you can imagine this as something like Docker-like environment where it will not have access to the internet. It will be completely isolated from the file system and so on. The idea of this sandboxing is, of course, for the build to be reproducible and only dependent on these inputs. That is one of the core design decisions. And as I've previously mentioned, all these inputs are then calculated. There is a hash calculated out of these inputs. And this uniquely identifies how this package was built and, what is the source of this package. So not just the source, the binary of the thing, but also all the instructions for it. So the builder will take care of the building part. And this is where I previously talked about evaluation and building separation kicks in. So when you will install Firefox, it will find a Firefox file. It will evaluate this first. So it will evaluate the Firefox derivation and then everything up to the bootstrapping bit. And then once that's done, it will start to build. And the building phase is not that interesting. There's essentially two parts to it. One is that it will use these derivation files to call this builder, as I've mentioned. But before it does that, it will also check with this hash if there exists a binary package for it, and it will substitute it if there is one. And if not, then it will go and build this. How that works is that when the package is built, as I've mentioned, Nix will put it in the /nix/store. slash and then hash and name of the package, and then everything goes in there. And the same for all the dependencies. So let's assume now that Nix, downloaded some binaries as a dependency of Firefox, and then it built the Firefox. Now it just has a bunch of folders in /nix/store. And now it will link those into something, we would call file system hierarchy. Something you're used to, the standard that you're used to in Debian, for example. So /user
Right.
and /opt and so on. And it will just layer these things essentially together into something Nix calls profile. And this profile is really just one snapshot of when you installed a package or a group of packages, completely linked together. And so that's how Nix goes from this global store into an actual file system hierarchy that we're used to. And it's a one big symlink farm, the way to imagine it. This is then how you go through. If you install something, it will add that pack. It will install all the packages you had before and then this package on top of it. So it's kind of immutable. You build up these things. That's how I like to imagine this. Mm-hmm. And the same when you uninstall, it will not remove the Firefox from the /nix/store directory, but it will just create a new profile version without Firefox linked in. And this is very typical to memory management, right? Where you essentially just allocate and then you garbage collect when you want to. So Nix works in a similar way. So then actually the leading packages would be an explicit garbage collect operation, which will go through these profile versions and you can say, keep just the last one, for example. Yeah, so that's the garbage collection bit. But let's go back to installing. So now you have this profile where Firefox was installed in, and then Nix will activate it, which means that the specific snapshot of the profile is now the activated one. And these profiles can be stacked one upon another as well. And there is the user profile. So each user can have a profile. Each user can install their own set of packages. And then on NixOS, the distribution, there's also a system profile, which is the actual OS profile. That then represents the environment that you access. And then Nix exposes, in a typical package manager, Firefox in the path variable, for example.
Mm-hmm. So how does it accomplish that? So I understand completely because it has /nix/store /unique hash -Firefox or whatever. I understand how that provides for multiple versions installed in the same system, right? I can upgrade. And I also understand how once you have this ever adding system where you're just adding a new install of Firefox and you still have the old ones, unless you garbage collect, how you could do your atomic upgrades at that point, because now you're just swapping the symlink between those versions. And like you said, that's atomic. That's an atomic operation in Linux. So it's the small, happens in a split second. And so that's really good. It doesn't explain to me the multi-user support. So you said there's profiles. Is everything stored in the Nix store? And then it's just the profiles are elsewhere and point to which versions you are using? Or how does it know when it's garbage collecting that Adam's profile has this Firefox, but my profile has a different Firefox? How are those segregated?
The easiest way to imagine it as a file, Debian installation would be one profile, right? And then you have different profiles in your system. The way Nix stacks those together is, if I understand your question, is it will just append the path, by the hierarchy of the profiles you have activated. So if you have a user one and a system one, then the user one will append the bin path of the user profile first, and then the system profile bin path will come second. So then all the packages that are installed in the user profiles come from the user profile bin path, and then the system one follows.
Okay, that much I understand, but how does it know not to garbage collect my profile's version of Firefox when you run garbage collect?
Oh, okay.
Is there some sort of registry of who's using what, where?
Yeah, so the profiles are symlinks as well. They're stored in the /nix/var/profiles, I think. And for each profile, there is a name, and then there is a something called profile, and then the version of it, 1, 2, and so on, counts linearly. And inside there, that's the symlink then to the file system hierarchy. So when you run garbage collect, you can do it for the user or you can do it globally. Oh yeah, you can pass a link to, if I remember correctly, to the profile you want to garbage collect. Otherwise, it will garbage collect everything. And the way the garbage collection works is you can say garbage collect everything that is not in the profiles. So, just some things like, so for example, when you build something, not everything ends up in the profile because they're just tools that were needed when you build something, but are not actually part then of the runtime paths. So you can just collect those, garbage collect those, or you can garbage collect to say, delete everything up to, so that 20 gigabytes is freed, or and so on. There's quite some flexibility in there.
Gotcha.
So the profiles essentially bless what's installed, and when you garbage collect, if it's present in a profile, then it's like, hey, I'm not going to touch that because that's necessary based upon somebody's profile that's established, whether it's Jared user or my user.
Exactly.
And then likewise, if Jared wants to install something that I've already installed, it's not going to re-download and recompile and rebuild that a second time. It's going to just use what's already there, which is secure because you can't kind of go and change that. It's got that hash. It's already been built. It can't be muted, essentially. It can't be changed and then Trojan horse be dropped in there or something like that.
Yeah, exactly. Yeah. Nix Store is mounted as read-only, so only Nix kind of is allowed to manage it, essentially. Yeah, so that's the guarantee you get.
So since we compared Nix as a analogous to how somebody might be familiar with apt or apt-get, does apt or apt-get or homebrew, are they not in this kind of world where it's reproducible? Is that not a concern in those worlds, or is that not a scenario? When I run apt-get install Git, for example, I suppose I can apt-get install Firefox or something like that. If that's the case, am I just grabbing what's in the registry and pulling that to my machine? Because I'm not making or building there, right? In most cases, unless it's something that needs to be built.
Right.
So Nix is reproducible in the fact that it runs on reproducible builds, and the fact that it makes these builds hashes secure by nature because you can prove the complete dependencies, what was involved, all that good stuff, and that hash proves it, and that's the way it works by design. How does that compare to apt or apt-get? Did they not do that?
Yeah, that's a very good question. I think there are actually two kinds of reproducibility that are usually, I would say, mentioned in the package management world. So Nix does the reproducibility where it goes from source to a binary by ensuring that you always kind of get the same binary. And this is then minus some discrepancies of system time getting into the binary output and so on. But the guarantee is that using the same hash, the same kind of sources and inputs, you always get the same binary. On Debian, they have also the reproducibility project, but that is more about the binary output, so that the actual binaries you get are identical each time you build something. The difference is that in Debian, as far as I know, maybe the infrastructure has changed recently, but it used to be at least the case that when you build something, it will pick up libraries from your system, right? So when let's say you build Firefox, it will pick up OpenSSL from your system. Now, how this OpenSSL was built there is no guarantee, right? Something built it. And of course, if you use Debian to install OpenSSL, then you kind of have this guarantee implicitly on your system. But anyone, you could easily swap out OpenSSL with the newer version or the lower version and so on. So there is no tracking of it. The way I reason about Debian is there's just some kind of a file system state where you installed OpenSSL and then you install another library that depends on it and so on. And then you stack these. But yeah, as I've said, there is nothing tracking what really was used to install this. So of course, Debian probably has some servers where they build this in a sandbox environment and so on. But when you do it locally, you kind of lose that guarantee, right? In Nix, everything is sandbox by default. So everyone that's building anything on Nix gets this guarantee, and it's enforced. So yeah, that's the main difference between the two.
This episode is brought to you by CloudZero. CloudZero is the only cloud cost intelligence platform that puts engineering in control by connecting technical decisions to business results. This is crucial for software-driven teams focused on growing their margins. By analyzing cloud services like AWS and Snowflake, CloudZero provides real-time cost insights to help you maximize your margins. Engineering teams can answer questions like, who are my most expensive customers? How much does a specific feature cost our business? And what is the cost or impact of rewriting this application? With cost anomaly alerts via Slack, product-specific data views, and granular engineering context that makes it easy to investigate any cost, CloudZero gives you complete cloud cost intelligence. Connect the dots between high-level trends and individual line items. Join companies like Drift, Rapid7, and SeatGeek by going to cloudzero.com/changelog to get started. Again, cloudzero.com/changelog.
So Doman, one of the things you said at the top, and also you say on Nix ecosystem, is a DevOps toolkit. So there's a DevOps focus in what Nix is providing. So not just merely installing Firefox on my local Linux box so I can browse the web, but like using this for getting your DevOps, getting your stuff out there in the world, right? Taking your software, putting it out there, whether it's a web app stack or whatever it happens to be. And so that makes me wonder how it fits in with other DevOpsy things. And would you use Nix plus this configuration language to create these isolated installs, and similar to like a universal binary kind of idea where you're like, just take this folder and put it on another machine and it runs? Would you use it instead of Docker? Would you use it with Docker and Docker Compose? Just help us understand where Nix fits in as a DevOps thing, where I might use it to deploy some software.
That's a great question. Yeah, I don't think there's a definite answer to it.
Okay.
Essentially, there's all the options.
The answer is yes.
The answer is yes. Again. Yeah, so the way I see it, at least first compared to Docker, Nix is really good with the configuration and build part. And once you build something, then when you run it, it's just an executable. So Docker is, I would say, complementary to that. So Docker provides the runtime isolation between things. In the NixOS, we use systemd, so since the very early days. So that one kind of manages the whole runtime bit, if you use the OS bit. But if you use containers, then there's people who are using Nix to build containers for Nomad and, Kubernetes as well. And yeah, you can build Docker images with Nix. And I think that's a pretty nice combination as well, because one thing I forgot to mention is in Nix you have two kinds of derivations really. One is called fixed output derivation, and the other one is just a derivation or dynamic derivation. So the dynamic derivation is the one that hashes all the inputs. The fixed output derivation is the one that has the hash up front. So you can say, oh, this is a SHA something. And that one actually has now network access. So whatever it will build, the SHA you provided should be the hash of the content that this, that this builder will do. So this is a pretty nice guarantee that everything you get from the internet has a predefined hash of it. And everything else that doesn't access internet then depends on that. And in the Docker world, this is not the case. So if you have a Docker image that, downloads something from the internet, essentially, if you run it twice and that content changes, there is no guarantee whatsoever that this will be a completely different, image with different output. The reason why people don't really notice that is because Docker Hub kind of has the history of all the images and people don't usually build them themselves. But yeah, that's where I think Nix shines better. So in this reproducibility aspect, and then Docker from runtime for sure, and all the container stuff we've built recently helps a lot.
So you're effectively running Nix alongside Docker or inside of Docker. to do all the package stuff. Is that the way you would use it?
Yeah.
Together? You said they're complementary. You use them together that way.
So there is an official Nix image where you have the Nix installed and you can build stuff inside the container, the Docker containers. But there is also an API in Nix language so that you can build images with Nix, which is pretty cool as well because you will get very minimal images compared to stacking them up as people usually do. You have like whatever you build, which depends on something else and which depends on Alpine Linux and so on. So this quickly adds up. Whereas if you go through the Nix route, you just build your thing and then you copy that into the Docker container and it has nothing else, essentially. It's also potentially faster, but let's not go into those details.
Yeah, I saw a cool example on the examples screencast where it was setting up a Docker image that had a specific tool where it showed 3 versions. It was like the stock Nix version, stock Debian, and then the Alpine Linux. These are the containers, the images. And at first, the Alpine Linux one was just teeny tiny, of course, because it's just a stripped down version. And the Nix one was like somewhere in the middle of the other two. And then the screencast goes in to show how it could, instead of taking just the default package, that's the Nix package for this particular piece of software. I can't remember the software, Nginx maybe it was simpler than that. And instead of merely using the precompiled binary and putting that in its image, it would go in there and just tweak a couple flags, like a compile flag, and then it like removed some sort of subdirectory that it didn't care about. And it was able to achieve a image that was even smaller than Alpine Linux's just through those couple of tweaks. So that kind of speaks to the thing that you like about it with it's convenient by default, but then it's also has the customizability where you can have the pre-built binaries. You can just use that. No big deal. You don't have to compile everything. But when it comes time to say, you know what, I really want to strip this thing down and make it as tiny as possible, and I know I don't need this sets of files, or I don't need to compile for these 7 whatevers, I can go in and through that Nix configuration language, just make a couple of changes to the way that particular piece of software is compiled, pass it some flags, have it compile for you, and reap the benefits. That was pretty cool.
That is one of the most powerful things. Like, for example, going back to the Firefox, let's say you would package Firefox in Docker container. Each package is essentially just a function of all the dependencies it needs. So like, OpenSSL is a parameter in that function and so on. So you could say OpenSSL override, flip a flag or apply a patch. That's the most common one. Like here is a patch. And you could apply a patch to OpenSSL, which then is provided as an argument to build Firefox. And that's like one line to tweak. So I think that's really powerful compared to if you then go tweak those Docker images and trying to rebuild them, which are not exactly reproducible and so on. It becomes a mess pretty quickly.
So a couple of the other features that I'm not sure we've hit on exactly that I think play into the ops side is you list remote builds and remote deployments. What exactly do you mean by remote deployments?
Right. Yeah, maybe that's a weird way to put it.
Okay.
As I said previously, you can control where it's built and you can then deploy from one machine to like 20 others, for example. Now, Nix will either copy what it needs there from your local machine or it will substitute from a binary cache. And so really remote there means that you're not really doing anything on that machine except copying them and then activating the NixOS. I'm talking about the OS bit here in case there's also these only true profiles, but that's not as convenient by default. So that's the remote part.
And what would be an example of why you would want to do that? Would it be for cost savings on the wire or caching, or would it be for what reason would you want to do that?
So you're saving all the resources. So usually where you're deploying to is optimized for the runtime features of your thing, right? So a very good example of this is if you have like Raspberry Pi, You kind of don't want to compile stuff on Raspberry Pi. You would mind to compile on a easy to ARM V8 machine.
Right.
So then, like, essentially, no, it doesn't require any extra disk space. The thing you copy to the Raspberry Pi is exactly what the system needs. So it's really fast, right? As this is as fast as it gets from getting the system up and running. You copy it over and you activate it, you start a script, and that's it. You don't use any of the CPU or memory resources besides the constant memory copying.
Right.
Also, it doesn't like interfere with the system that much, right? So if something is running there and it's really on the edge, like it's essentially untouched that way.
Gotcha. Well, that Raspberry Pi is a very good example that clarifies to me why that would make sense. You totally want to do that.
Mm-hmm.
Cool.
Where's the interesting things happening around Nix? If Nix has been around for 20 years, and we're now at roughly year 20-ish of its inception. When you look at the ecosystem at large, where are the cool things happening? What's happening? What's being done that's sort of bleeding edge around things that's really got you personally excited or the community excited?
Right. That's a pretty broad question. One of the things that I've been doing in the last 4 or 5 years is I think we need to build infrastructure and documentation. Those are the two main things I'm working on. So in other words, I think we should go into commercialization, or, what I like to put it, to go mainstream by really making it easy and accessible for people. And also, as I said, building infrastructure so that deployments, builds, and all these things are done very easily, and companies can just, subscribe or pay for a subscription and, roll their own stack. That's one part of it that I'm, mostly concerned about. There's also, on the community side, there's a lot going on. We had a couple of conferences. So the community is growing pretty fast. We're having issues with actually a lot of people coming in. So we're trying to do more policy stuff so that we can grow faster and then less chaotic. And on the research side, there is a bunch of new things coming in. One thing is called Content Addressable Store. So this is quite similar to what Bazel does. Yeah, I'm not sure if I should go into explaining that because it's really in the phase of development right now. But essentially, it's an optimization of when you build, like in Nix, if you rebuild something that is in the beginning of the dependency tree, let's say, Bash, you have to then rebuild everything that depends on Bash. What content addressable approach allows you to say is, if the derivation output of Bash is the same as it was previously, then you don't need to rebuild the rest that depends on it. And this completely needs a different design. So maybe Bash is not the best example, but let's say if you would modify Git and then, Firefox depends on Git, then Firefox output probably wouldn't change even though you have changed Git. So Firefox wouldn't change, and anything that depends on the Firefox then wouldn't need to be recompiled, for example. That's one of the... there is a really cool paper called Build Systems a la carte that unfortunately doesn't have Nix inside, but it compares different build system and different features they have. And Nix will then tick all the feature boxes once this feature is complete and be essentially, I would say, better than Bazel in that sense. So that's one of the areas. The other thing is there's a bunch of work on the usability side. It was clear that it was a research project. So we're Eelco Doolstra and also a bunch of people from community are redesigning the command line that it's easier to use. So I think we're kind of at the, again, phase of bringing it closer to the wider audience. And command line redesign was a big part of it.
Gotcha. Well, you mentioned a lot of growth is happening now in terms of community. Are you familiar with where that growth is happening, potentially where it might be coming from? And I know that a lot more people are using Raspberry Pis, for example. I know that Nix has that support. a lot of home labs are sort of built around Raspberry Pis and things like that. Like where do you see the support, or where do you see the growth kind of happening? What areas of the Nix ecosystem seems to be the most on fire, so to speak, in terms of growth?
I think the biggest one right now is actually Haskell community, because it's so closed conceptually to Nix. I would say this is probably a hard statement, but most of Haskell teams are using Nix to deploy or build Haskell one way or another. And so a bunch of other languages where this is useful as well. I would say there's a bunch of people in Rust community, and other languages as well. And I think in DevOps, especially deploying and managing systems, I think there are more and more companies using Nix, because this reproducibility part and just assurance in general is useful to them. Well, actually, my friend Nate told me this one. I really like this concept is that, Nix is kind of like when we had PHP and you would hack on the live server and all of that was, back in the days considered as accepted and, practice. It's the same with Nix now. So if you go to a Nix machine and you just try to edit some files, it won't work. You have to edit the Nix files and redeploy. So this usually creates a bit of resistance from people who are used to Debian, for example. So Nix kind of turns operational tasks into development tasks. So you kind of have to pay this cost up front of actually, describing your system in one file and so on, which takes some time. But once you do that, you save a lot of operational problems. So we see a lot of people figuring this out in the wilds and then coming to Nix as lessons learned.
Gotcha. If someone's listened this far, they're like, man, this is interesting, somewhat interesting to me, whatever. Like, where's your go-to place to get started? Is it nix.dev? Is it another place? Where do you send people to sort of, obviously they've maybe gotten past the reproducible builds, understanding the reliability of that, potentially even the extra security of what that means. Where do you send people to get started? If they're DevOps, do you send them to a certain place? If they're from Haskell, do you send them to a certain place? Is there a different place for different camps? Like, where is a good place to kind of like kick the tires, begin, get started, play around, and, maybe fall in love?
Right. Yeah, I'm still working on nix.dev. I think it is a great place to start, although it's not complete yet. So there are parts that are missing. The typical place to start is to read NixOS, the manuals. There is a Nix manual, which is specific to the language and package manager, and NixOS manual, which is about the OS bit. But those manuals are kind of like not tutorial-like. They're more like reference documentation and like description of different bits of NixOS and how it works. And that's where I would like nix.dev to be the middle ground, where you have tutorials to get started with. So I think between those two, if you want to go really deep into Nix as a language and how it works, there is something called Nix Pills, where it kind of goes into different parts of Nix and explains the concept behind it. And there's a bunch of people, there's on YouTube a few people who have recorded videos. There is Nix Shorts, someone wrote, which is like a short tutorials of getting started with doing stuff with Nix. I think that's everything that comes to mind right now. The main one, I would still say NixOS manuals if you want to get your hands dirty.
Gotcha. We'll link this up in the show notes. nixos.org is kind of a good landing page, but we'll link deeper into, say, manuals and pills, and obviously link up nix.dev, and we'll look up Nix Shorts on YouTube. I found something else. I think it may be a false positive, but we'll dig further and provide awesome links. Listeners, find that in the show notes. Doman, thank you so much for this deep dive on Nix. It's interesting. I've never personally used it, but I can certainly see the reproducible builds idea around it, especially the usability around ops. And, you want systems you're putting out into production to be secure and stable and, be able to count on those. So I can see where Nix really plays a role there. But thank you so much for your time today, and appreciate you sharing your wisdom here. Thank you.
Thank you for hosting me.
That's it for this episode of The Changelog. Thanks for tuning in. If you aren't subscribed yet to our weekly newsletter, you are missing out on what's moving and shaking in software and why it's important. It's 100% free. Fight your FOMO at changelog.com/weekly. Huge thanks to our partners, Linode, Fastly, and Launch Darkly. When we need music, we summon the Beat Freak Breakmaster Cylinder. Huge thanks to Breakmaster for all their awesome work. And last but not least, subscribe to our master feed at changelog.com/master and get all our podcasts in a single feed. That's it for this week. We'll see you next week.